are we looking? Oh, R?
Yeah, oh yeah, the range. So it equals V naught x times time 2.
V sub x times time sub 2.
Right. Which is also equal to, if we use this as our T2, then we use V naught cosine of theta as our V naught x. So it becomes 2 V naught squared cosine of theta sine theta all over G. Is that what it has?
That's what it has there.
Oh, and then it's saying the cosine of theta times the sine of theta is equal to cosine, or the sine of 2 theta.
Okay.
So anyway, the point is they're just explaining how they got these equations. So 2 V naught squared sine of 2 theta all over G.
Okay.
And then it's just reminding you that it only works on flat surfaces. So honestly, like these equations are kind of good to know sometimes because it shortens the amount of time. So what it's saying is if you know this equation and you're given a problem where it says, okay, you launch something at an angle of 45 degrees going at 35 meters per second. It's going to fly out here and land. How far did it go?
Okay. We did one of these on the board. I have no idea. I got lost.
Yeah. So if you want to find out quick using their equation, you can say, all right, well, I'll take 2. So my range is going to be equal to 2 times V naught, which is 35, squared,
Okay.
times the sine of 2 theta, which is 90, all over G. G goes to 9.8.
Okay.
So then you can say, well, whatever 35 squared is, the sine of 90 is just 1. And then you divide it by, so you do, the range is going to be equal to 2 times 35 squared all over 9.8.
2 times 35 squared. 250.
Yeah, so if you shoot something at 250 meters.
That's actually kind of cool.
Yeah, I mean, it works just like that. It's pretty simple, pretty easy. How long did it stay in the air? Well, you can just say, well, T2 is going to be equal to, so my time is going to be equal to 2 V naught, so 35, times the sine of 60, or yeah, sine of 45, all over 9.8. That's this equation. So how long was it in the air?
Let's see, 2 times 35 times the sine of 45. Divided by 9.8. T equals 6.0779. 6.8.
So then you know it flew 250 meters and it took 6.8 or 6.08 seconds to get there.
That's cool.
So they're pretty useful until you change the problem and you say you're launching at an angle of 35 meters per second and you want to land on top of a cliff that's 40 meters tall.
Okay.
Or even if you don't do that, say you do something like this. You launch at 15 degrees, 20 meters per second, Now how far do you land? So in this case, say this is 15, let's make this 35 meters. Now, those equations don't count for anything. Can't use them.
Okay.
So-
Okay, so it's just pointing out that it only works straight across.
Yep. So it only works if you're doing something like that picture shows,
Yeah.
where you start from 0, you start at your x point, like your x and y point are the origin, so right here, and you launch out and you end back at 0 somewhere.
Okay.
So they're really useful until you start twisting or changing that a little bit. And that's kind of what they do to you in problems, seems like. They'll switch it up on you.
So that wasn't even a question? That was all just.
No, that was just
pointing out.
explaining those equations, but then the question is,
Which of the following changes would increase the range of the ball shown in the original figure? Check all that apply. Okay, so that's where they want you to understand all this means.
right, so if you want to increase the range, which of these equations do you want to look at?
I'm sorry, what was the last part of that?
So you have two equations,
Mm-hmm.
one that talks about time, the other one talks about range.
Uh-huh,
Which one are you trying to increase?
the range.
Yeah, so you take your range equation. Okay. And then, what are your options? It says increase V naught.
About 30 meters per second.
So what would that do in this case?
Shoot, that's, where did we start out? Were we at 30? It didn't give us a,
Yeah, that was that. You remember how we added some numbers to find like the 15, 26?
uh-huh,
Originally, so initially this started out, like this. It started at 30 meters per second at an angle of 60 degrees.
uh-huh,
It flew out, landed out here somewhere. This was our R.
okay.
So would increasing 30 give us a greater range?
Yeah,
Yeah, because we plugged that in here. And so any increase in this will increase this top part.
right,
So increasing greater than 30 will definitely increase your range.
okay, so reducing V naught below 30 meters per second would not increase the range.
No.
Reducing theta from 60 degrees to 45 degrees, that would reduce the range, wouldn't it?
So let's think about which term will
No, that'll increase the range.
yeah.
Okay,
Because if you look at this,
if you went steeper, you'd lose range.
yeah, so the sine of 2 theta at 60 is going to be the sine of 120 degrees. So it's this.
Mm-hmm.
Versus the sine of 2 theta at 45 gives you 90. Right?
Mm-hmm.
So we know that the sine of 90 is always, it's 1. That's the highest the sine can ever be.
Okay,
The sine of 60 isn't, or the sine of 120 isn't going to be quite 1. So at 60, this is going to be a little bit lower than at 45. So yeah, bringing it down to 45 will increase the range.
okay.
What else?
Reduce theta from 60 degrees to less than 30 degrees. So at 30 degrees,
So think about it in terms of 2 theta again. We said 2 theta of 60 is going to be 120, right?
uh-huh,
Which is really just So this is 120. So that's really just the sine of 60, right?
Uh-huh.
Sine of 120 is the same as the sine of 60. So then what if you decreased it to less than 30 degrees? What's the sine of 2 theta going to be then?
I don't know.
Well, if it's less than 30, then we know that the maximum, so if, let's see, yeah, let's do this. So theta is less than 30. So then we multiply by 2. So 2 theta will be less than 60, right?
Okay.
So we can draw the same thing over here. We can say, well, 2 theta is like this, and it will be less than this. The sine of 2 theta will be less than the sine of 60.
Okay.
So if originally we were at the sine of 60 times this, and now we decrease it, we say that this is going to be less than the sine of 60. Will that increase our range or decrease our range?
And we were at 30 originally?
So I'll draw this out a little bit actually, because according to this range equation, because of the way it's set up, here's what happens. You have at 45 is a sweet spot.
That's you're going to be your furthest
Yeah.
range.
At 30, you're going to kind of come and it'll be a little short.
Uh-huh.
But what if you go, so 30 is 15 degrees this side of 45. What if you go 15 degrees this side of 45? What do you think is going to happen? So you go to 60.
I would imagine that it's going to land kind of close to 30, where 30 lands.
So this is 30 degrees, it's 45 degrees. Turns out it's exactly where it lands. It's right here.
Okay.
And then same thing if you come all the way down to 15 degrees, it's even shorter,
Or if you go,
up to 75 degrees. It'll land at the same place as 15.
okay.
That all comes down to this right here. So the sine of 2 theta.
Did you ever play the video game Scorched Earth?
Mhm.
It's an old video game. And
I played tanks.
Yeah, it's like, that's the same
Yeah.
thing, is where you enter your,
Yeah, your
velocity,
projectile,
your angle,
what you're
and-
shooting, your velocity, your angle,
Uh-huh.
exactly. Yeah, it's exactly the same idea. And the reason it works is because of this. But in that kind of setting, you had your tank down here, whatever, and you're shooting up some mountains or whatever.
Yeah,
So that's kinematics, but that's kinematics without this kind of a flat level ground. So on flat level ground, if you shot it at whatever angle, it would land in the same place.
okay.
So, but it comes down to this 2 theta thing, because the sine of 2 times 45 is the sine of 90, which is 1.
Okay.
The sine of 2 times, what did we say, this was 60, or, so the sine of 2 times 60 is the sine of 120. Remember when we draw that out here?
Mm-hmm.
Which really is the same as the sine of 60. See that?
Okay.
So that's the same as if you went sine of 2 times 30, gives you the sine of 60. Those two are equivalent to each other. Then you go one step further. You say, well, the sine of 2 times 15 equals the sine of 30. The sine of 2 times 75 equals the sine of 150. Well, when you draw those 30s over here, 150s over here, and they have the same sign. So these two are equal to each other. These two are equal to each other, but they're less than those two. Those two are equal to each other, but they're less than this one.
Okay,